Welcome to my channel, everybody, and this is the another video for I have sent you for the competitive exam a question paper to my another video, and that the last part of this question of that question, okay, and see some problem like 42 to 48 here. Okay, now we have to solve this first. F of x is equal to a sin x into 2 into cos x by sin x plus cos x. It is increasing for values for what is greater than, less than, and something. Okay, and now see if we differentiate this, we get, if we differentiate this 48, question number 48, f of x is equal to a sin x 2 cos x. And you know the differentiation of all the functions, student. So you have directly written f dash x is equal to that is a minus 2 and divided by actually sin x plus cos x whole square. Okay. So we get this actually if we first order derivative is this. Okay, and this is increasing, and it is given that this is increasing, so it would be a greater than equal to 0. So therefore a minus 2 greater than equal to 0. Okay, sorry, this is only greater than 0, so that is a greater than 2. So this is the option D. This is the option D here. Okay, and for increasing function. And now 49, we have to do the problem 49. This is the form of an infinite series of GP, and hence 0 is the value of that. And for that, this is the recurring signs, and this is 0.4444 to infinity. Actually, this is can be written like that, 04 plus 0.004. Okay, this is an infinite GP, so this is a by 1 minus r. This divided by this, and this is r equal to 0.4 divided by, and this divided by this. Okay, that is 0. Okay, and 0.4 here, and this is here. If you multiply by this is 100, and this also 100, then 4 by 40, and this is 1 by 10 here. Okay, this is 1 by 10, so 4 by 10, and this is a 9 by 10. This is 4 by 9. Okay, and from that if we find the value of 2 by 3 here, and now from 0.66, and this is 0.666 to infinity, same as 0.6 plus 0.06 and to infinity. Okay, and that's why this is by 1 minus this is 1 by 10 here. Okay, naturally, and this is 6 by 10, and this is 9 by 10. So this is 9 by 10, and that would be 2 by 3 here. See, these are same, so we can easily write that 0.444 to infinity is equal to 0.666 to infinity. Okay, now from 50 express this as a rational pattern. So let us assume this is the x, which is given that 0.423, and this is the recurrent sign, and this can be written as like 2 3 2 3 2 3 like that. Okay, if we multiply, sorry, if we multiply by the number like 2 3, okay, 2 3, so multiply by 1000, so 1000 x, and that would be a shifted point in that position, that is a 4 2 3. Again, first we multiply by 10. Okay, then we get here 4.232323. Okay, and then again it is it is multiplied by the 100, and this part will be multiplied by 100, then it is this is 2 3, okay, this is 2 3 2 3 and dot dot dot, again 10x, this is actually we can easily from an infinite GP, this is a GP series, so 4 plus this is 2 3 by 10, 2 3 by 100, and 2 3 by 1 2 3 4, okay, this is okay, and this is 4a, this is 23 by 100 and divided by 1 minus this divided by this, and this is also 1 by 100 here, so this is 23 by 100 and this is 99 by 100, so 23 4 plus 23 by 99, okay, and this is the rational pattern, okay, this is the rational form, so you can write here this is 10x, therefore x is equal to 4 by 10 and 23 by 990, and just you have to take LCM, then we get a rational pattern, okay, so okay, this is the form of the rational pattern. Now next problem, in a question, the number of zeros between the decimal point and the first significant figures in the value of 75 to the power minus 8. Now take a log on that number. So see, log of to the base 10 actually 75 to the power minus 8. So this is minus 8 log 75. We can write here 25 and this is 3 here. So this is minus 8 and this is 5 square, okay, 2 log 5 and this is to the base 10 and log 3 to the base 10 actually, in the given value this is the log 2 and log 3 are given but log 5 are not given, so that's why 5 can be written like that, 10 by 2 to the base 10 and this is log 3 to the base 10 here, okay, this is minus 8, this is 2 log 10 to the base 10, this is again 2 log 2 to the base 10 plus log 3 to the base 10. Now this is here minus 2 and this is 2 minus 2 into log 2. Log 2 is the value is 0.30103 and the log 3 is here 0.47712, and if you multiply by that number, and that is here 1.87, 1.8, 1.875, 1.875 and multiply by that number, we get here minus 15.000 and something. So this number shows that the significant zeros, number of zeros between the decimal point and the significant figure is 15, okay, this is B is 15, so B equal to 15, okay. And now 43, now to the question number 43 here, and this is log x2 to the base 2 log x to the base 4 log x to the base 6 equal to log x to the base 2 into log x to the base 6, and so that's why you have divide these three logarithm on the both side, then we get here 1 equal to just we have right here log x base to the 6, and 1 by for the second log x base to the base 2, and the third 1 by log x base divided by and to the base 4 here. Okay, so from that, and we can write here log to the base x is 6 here, same as log 2 to the base x, log 4 to the base x. So we can write here x base x, and that's why 1, and this is here to the base x. So we can write here x is x into 6 into 2 into 4 actually. So from that x is equal, we can write 6 8 actually 48 actually, and this is the solution of x. So solution of x is here. We get here 48. We get here 48. Six, 2, 4, only 48. I think this value are roundly given, so that's why we get here only 48. Six, 2, 4. It's nearly 1. So doesn't match the option, so only 48. Okay, see the solution carefully. Now okay, and this option is right here. 1, as the question is this, one also are satisfied. One also are satisfied. If one put here 1, then this 0, 0, 0, 0 are equal to 0 also. Okay, but in case of 1, we can't express this type of expression. Okay, so 1 or 48 are correct answer. Now as the formation is given 43 like that. Okay, in case of we get 48, we can arrange like that, either this or this. Okay, now 44. 44, very interesting question. 44, limit y tends to infinity, and this is 1 plus a by y b by y square and whole to the power twice y equal to e square. Then find a and b, and c, let 1 by y is equal to x, as y tends to infinity, so x tends to 0. So this is here x tends to 0, so 1 plus ax bx square to the power 1 by 2 by x, and this is e square. So from that, let us assume as a z, and z equal to ax plus bx square. So ax square bx square, ax minus z equal to 0. So we get here x is equal to minus b plus minus root over b square minus 4ac minus 4ac, this is plus bz by twice a. Okay, so from that we can write here limit x tends to 0, 1 plus z, and as needed to get a formula. So that's why this is 1 by z. We can write here 1 by z. Then it would be a E. And now we get here balancing for z. This is 2z. Okay, and this is x. X means take a one value like minus a plus root over a square plus 4bz and by twice b. So twice b. So this is shifted to that. So 4 or b z. Okay. So see, this is actually e square and this is actually e. So it is e to the power, as x tends to 0, so you can put here z, sorry, this is 0. So z tends to 0, limit z tends to e to the power, this is e to the power, limit z tends to 0. This is here 4bz by root over a square plus 4bz minus a, and multiply by the other factor like root over this plus a, and same as root over this plus a, and this is equal to e square. And we get here, so e to the power limit z tends to 0, actually a square 4bz, a square plus 4bz. So this is here a square plus 4bz minus a square, so 4bz, and this is root over a square plus 4bz plus a is equal to e square. So see, a square is cancelled, 4bz are cancelled. If we put 0, then we get here, this is 0, a square a plus a, this is twice a, and this is a square. So we get here twice a is equal to 2 and a is equal to 1. Okay, now for finding b, see the technique from that. So limit x tends to 0 and 1 plus ax bx square, that is 2 by x is equal to e square. Now again we write here limit x tends to 0, 1 plus ax plus bx square bx square 2 are cancelled on both sides, and this is also, you can write here limit x tends to 0 e to the power x e to the power x. So from that again we write here limit x tends to 0, 1 plus ax plus bx square minus e to the power x equal to 0. So limit x tends to 0, 1 plus ax plus bx square, 1 minus x by factorial 1 minus x square by factorial 2 minus x cube by factorial 3 minus dot to infinity equal to 0. So 1 are cancelled. So now limit x tends to 0, x a minus 1 plus x square b minus 1 by 2. Okay, so left all are, we get here like x cube by factorial 3. Okay, so this is, and this is equal to 0. but x never be 0. This is x tends to 0. So we can write here x tends to 0, a minus 1 x into b minus half, and this is equal to 0. Okay, therefore a minus 1 equal to 0. On the right hand side I have 0 plus x into 0 and like that. So a minus equal to 0, so a equal to 1. And the value of b and all the real values of b. So which is true here? Okay, that's not also giving that value of a is 1 and all the real values of b. Okay, for next problem, this is 45. See, this is 45 and this is here given that f double dash 0 is equal to 4 and limit x tends to 0, 2 into f of x, 3 into f of 2x plus f of 4x by x square. Okay, find the value of that. So from this we can easily write limit x tends to from that we can easily solve the El Hospital rules, but without solving the El Hospital rules for finding the value of that. So we can write here f of 4x, f of 4x minus f of 3x plus f of 3x minus f of 2x. Okay, plus taken common 2 here, minus 2 f of 2x minus f of x. See sorry see the technique of writing is that, okay, twice times of that, 2 times of 2f of x. Okay, limit x tends to 0, this f of 4x minus f of 3x by x square by x, and this is f of 3x minus f of 2x by x. This is 2 into f of 2x minus f of x by x in 1 by x. Limit x tends to 0, this is f dash, you can write here f dash 3x, and this is here f dash 2x, 2 times of f dash x by x. Limit x tends to 0, f dash 3x minus f dash 2x by x. Okay, plus 2 times of, we have taken common here, f dash 2x minus f dash x by x. Okay, so this is here f double dash 2x plus 2 into f double dash x and this is equal to f double dash 0 plus 2 into f double dash 0, and the f double dash 0 is given that 4. So 4 plus 2 into 4, 8 plus 4, this is 12. This is 12. With the help of L'Hospital rule, we can easily solve this. So if we put here 0, 0, 0, this is f of 0. And this is 2 and 3, and this is 0 by 0, and this is 0 by 0 form. So we can apply that they differentiate and limit x tends to 0. 2 into f dash x, this is 6 into f dash 2x, and this is 4 into f dash 4x by 2x. Okay, by 2x, and this is equal to limit x tends to 0. 2 into, again if we put 0, this is 2 times of f of 0, and this is 6 times of f of 0. This is minus 4 times of f of 0 plus 4 times of f of 0. So these also are 0 by 0 form. Okay, now again differentiate. This is 2 into f double dash x. This is 12 into f double dash x. This is 16 into f double dash x, and this is 2 here. If we put here, this is f double dash 0 minus 12 f double dash 0, 16 f double dash 0 by 2. This is 16, 18, and this is plus 4, and this is 6 f dash 0 by 2. This is 3 into f double dash 0 means 4, which is again this is 12, and this is 12. So we apply these two methods anyway. So this is the L'Hospital rule, and without L'Hospital rule, now this problem. Now see the question number 46. See the question number 46. The rate of increase of population is proportional to the number of inhabitants of a country. If the number of population is twice after 30 years, in how many year the population is 3 times, and given that the log 3 to the base e is equal to 1.6 times of log 2 to the base e. Okay, so see, from the given statement, dn dx is proportional to, okay, the rate of increase of population is proportional to the number of inhabitants, is number of the inhabitant. Okay, this is t with respect to time t. So we can write here dn dt is equal to k times of n. So now dn by n is equal to k into dt, and this is the integration, and given that if the number of inhabitants of the country, if the number of population is twice after 30 years, if 0, then this is n naught. After 30 years, this is the population will be twice n naught. Log 2n naught by n naught is equal to k into dt. This is t. This is k time of t, and 0 to 30, and this is 30. So therefore k is equal to 1 by 30 into log 30 into log to the base 2. Okay. In case of in case of this is n. Question is that in how many years the population is thrice. This is thrice. Okay, and this is dn by n, and this is k times of integral how many times 0 to t, and this is dt. This is log to the z 3n naught by n naught. Okay, this is k value is here 1 by 30 into log 2 to the base z, and this is t. Okay, this is t and 0 to t. So this is log 3 to the base z whole divided by log 2 to the base z is equal to 1 by 30 into t. So given that the log 3 divided by log 2 is equal to 1.6, so this value is 1.6, and this is 1 by 30 into t. Therefore the t is equal to 1.6 into 30. 3 6 18, 3 ke 3 4, 48 years. After 48 years the population be thrice. For the last question, find the domain of definition. So you can take easy technique, just root over 1 minus mod x by 2 minus mod x. 1 minus mod x is greater than 0, that is mod x is less than 1. Again also 2 minus mod x is greater than 0, so mod x is less than 2. Which is most probable? Most probable is here this, from these two. So required domain is mod x is less than 1, and another cases is here 1 minus mod x is less than 0, so mod x is okay, same as 1 minus mod x is less than 0, therefore this is here, okay, this is 2. Okay, which is most probable value? It is acceptable. Required domain is here more than 2. Okay. Okay, bye everybody. This is a very interesting class. See carefully. Okay. Actually, this number is 47. Sorry, this number is 47. This is 47, and this is 46. Okay. Bye everybody.